Mr. Moore's math class!
G'day guys and welcome to Mr. Moore's online math class. That's right, it's probably not the regular type of lesson that you're actually used to, because this type of lesson is all about you learning when it suits you best. That's right, and for example, if you don't understand something, what you can do is you can rewind it. And for example, if you don't understand something, what you can do is you can rewind it and then go through and watch it again and again and again until you get it and you make sure you understand what's going on. Alright, also in this type of class, what you can do is you can press pause at any point, go grab yourself a cold beverage, come back, put your feet up and watch the lesson from the comfort of your own couch. That's right guys, it is exciting stuff. I'm excited to be doing the lesson with you, but we've got plenty to get through today, so how about we get stuck straight into it. Let's go. Alright guys, today's lesson is all about sketching linear functions, but before we do that, what I want to do is show you a couple of little animations that will explain to you how and why we sketch these graphs, so let's check it out.
Now we're going to have a look at sketching linear equations. Now it's important to recognise that we sketch linear equations to basically demonstrate a pattern. Now let's have a look at these dots along the x-axis going from left to right. The first dot has a coordinate of -5, 0 because it is -5 along the x-axis and has a height of 0 along the y-axis. The next dot has a coordinate of -4 along the x-axis and a height of 0 along the y-axis, giving it the overall coordinate of -4, 0. Using the same method to find the coordinates of the third dot will give us a coordinate of -3, 0. The fourth dot -2, 0. Then we have -1, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, and 5, 0. Now what you can see is that I've written out an equation and drawn a straight line connecting the dots. I call this equation the how high rule because the equation will tell us how high each x coordinate needs to move in order to be on the line. So let's see this in a few different examples, shall we? In this example, the how high rule, or in other words the equation being y equals 2x, tells us that every x coordinate needs to be multiplied by 2 and moved to that height along the y-axis. And this is exactly what has happened because the x coordinate of -5 has been multiplied by 2 to give us -10, hence giving us the coordinate -5, 10. Multiplying the x coordinate of -4 by 2 gives us -8, hence the coordinate -4, -8. -3 times 2 is -6, hence the coordinate -3, -6. -2 times 2 is -4, taking this dot to a height of -4, hence giving us the coordinate -2, -4. And using this same process for the rest of the dots, you get -1, -2, 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, and 5, 10. Now in between each x-coordinate or dot that you can see here, we actually have an infinite number of other x-coordinates or dots. For example, we could have a dot at an x-coordinate of 1.1 or 1.2. Or we could even get closer and go 1.15 and 1.16. And we could still get closer again. So essentially what we do is we draw a line joining all of these dots to represent all of the millions of other dots that are in between each one of these coordinates that you can see here. As you can imagine, it's much easier to draw a line to represent these millions of dots than it is to create a table and go through and figure out the height of each one individually. So essentially we draw this line to represent the equation, or in other words the how high rule of y equals 2x, in order to demonstrate the linear pattern that's occurring visually rather than going through and having to figure it all out by hand, which hypothetically would take forever. Looking at the equation, or the how high rule of y equals -3x now, each x coordinate is multiplied by -3 and moves to this height along the y-axis. This is seen here with the coordinates of -5, 15, -4, 12, -3, 9, -2, 6, -1, 3, 0, 0, 1, -3, 2, -6, 3, -9, 4, -12, and 5, -15. And now we're able to draw the line to represent the millions of other dots that this equation represents. Note that the -3 out the front of the x gives the line a negative gradient. Now let's do the same thing but for the equation y equals x minus 5. So to find the height of the line for each x coordinate, what we're doing is we're subtracting 5 from each value of x. So checking it out now, -5 minus 5 is -10, giving us the coordinate of -5, 10. And let's skip a few points now because you're probably starting to get the gist of how things are working. Checking in at x equals -2 to see that we're still on the right track. So -2 minus 5 is -7, giving us the coordinate of -2, -7. Let's skip a few more points again. 2 minus 5 is -3, giving us the coordinates of 2, -3. And 5 minus 5, of course, is 0, giving us the coordinates of 5, 0. Once again, I've drawn the line to represent the millions of other dots that we haven't included. And if you note here, the -5 at the end of the equation is actually the point where the line crosses through the y-axis, that is the y-intercept. Having a look at the final example now, the equation, or the how high rule, is y equals -2x plus 4, meaning that for every x coordinate it is multiplied by -2 and then has 4 added onto it. -5 times -2 is 10, plus 4 is 14, giving us the coordinates of -5, 14. Stopping at 0 now, 0 times -2 is 0, plus 4 is 4, giving us a coordinate of 0, 4. And stopping again at 5, 5 times -2 is -10, plus 4 is -6, giving us the coordinates of 5, -6. Once again, we join the dots with a straight line to represent all of the other millions of dots that we have neglected in our table. Now if you take note of the equation, the number out the front of the x is -2, giving the line a negative gradient. And the constant value is positive 4, meaning that the line passes through the y-intercept of 0, 4. Summing up now, looking back on each one of the equations that we've just covered, it can be seen that these linear functions, or equations, simply just represent a pattern. Now these patterns are determined by the rule y is equal to mx plus c, and determine how high each x coordinate needs to move up or down in order to create the straight line. And for the general rule y is equal to mx plus c, m represents the gradient, or in other words how steep the line is, and c represents the y-intercept, that is, where the line crosses the y-axis. Now whilst a linear equation represents a whole range of points, you actually only need 2 points to be able to sketch a graph. So let's go to a quick video clip to demonstrate this.
Oh, look at me, I'm all alone. I can't even create a linear equation. I'm just one solitary point. If I throw it out here, it's not even a straight line. It's so disappointing. If only I had my buddy here, Jerry, so I could help make a straight line. Hey, hey! Hey, Jerry, you're here. We can make a linear equation now. Let's go. Hey, linear equation, one straight line. All you need is 2 points. Alright guys, so it's really important that when we sketch linear functions that we remember that we actually only really need just 2 points. And it just so happens that these 2 points generally happen to be the x and the y intercepts. So let's now have a look at a couple of worked examples of how to find these x and y intercepts and sketch linear graphs correctly. Let's check it out.
So now it's time to have a look at some worked examples on how to sketch graphs of linear functions. Now as you saw before, to sketch the graph of linear functions we must have the following things. Now the first one being 2 points. And these are generally the x and y intercepts, as you can see here. But sometimes graphs don't have the 2 x and y intercepts, sometimes they share the same x and y intercepts. Such as what you can see here, where you've just got the one x and y intercept where they both go through the point 0, 0, and that's the only way it's possible. And we need to find any other point which can be found by substituting any x value you choose. Now remember, to find the x-intercept we make y equal to 0 and solve, and to find the y-intercept we make x equal to 0 and solve. Alright, so this question says sketch the graph of y equals -x plus 6. So let's always find the y-intercept first, just makes it a little bit easier. So y-intercept, well we know that x is equal to 0 at the y-intercept. Therefore we're going to say y is equal to -x plus 6, just writing out the formula. Now we know x is equal to 0, so let's substitute in 0 for x. To get y is equal to -0 plus 6. Alright, simplify. Y is equal to -0, well that's just going to be 0 plus 6 is just 6, so y equals 6. Therefore the coordinates, we know that x was equal to 0 and y was equal to 6. That's the coordinate of the y-intercept. Alright, let's find the x-intercept. And of course, to find the x-intercept I make y equal to 0. Write out the equation once again. Y is equal to -x plus 6. Alright, make y equal to 0 now, so instead of writing y, I write 0 in brackets, is equal to -x plus 6. Rearrange to get x on its own, so I'm going to subtract 6 over here, is equal to -x. Divide both sides by the negative, gets us x is equal to 6. So therefore the coordinates at this point are x is equal to 6, and we know y is equal to 0 from up here. So that's the coordinate of the point. So now what I've done is I've just put in a Cartesian plane, and we're going to plot these points. So we're going to plot the point 0, 6. So we go across the x-axis to 0 and up to 6 on the y-axis. So that there is here. And we're going to write out the point 0, 6, because whenever you have a point of interest, as in an x or y-intercept, you must show it as a Cartesian point, which is this here. The x-intercept at 6, 0, so you go across to 6 on the x-axis and 0 on the y, being here, and you plot the point 6, 0. And of course, when you've got your 2 points, what you can do is just get a ruler and join them as such. Make sure you put the arrows on the end of the lines because it actually continues on forever. That's right guys, you've guessed it. Now it's time for you to sketch the graph of y equals 3x plus 9. Of course, like always, make sure you press pause before you do so, and then when you're done, check your answers against mine. Alright, so first of all, I found the y-intercept by making x equal to 0. Remember to write out the equation of the line first. Substitute x equals 0 in because we're finding the y-intercept. 3 times 0 of course is 0, plus 9 is 9, so y is equal to 9. Giving us the x coordinate of 0 and the y coordinate of 9, hence the point 0, 9. Right, to find the x-intercept, we make y equal to 0, so you've got y equals 3x plus 9, of course, writing out the equation again. Then we know that y is going to be equal to 0 for the x-intercept, so substitute 0 for y, equals 3x plus 9, subtract the 9 over to this side, and of course what you're going to do is divide both sides by 3 to get rid of the 3. That will go away there, so you get negative 9 divided by 3 is negative 3 is equal to x. And of course the coordinate of the point then is negative 3, 0. What we then do is use the point 0, 9, so you go across 0 on the x-axis and all the way up to 9, and we use the point negative 3, 0, so you go across to negative 3 and 0. You've now got your 2 points, and you can imagine the line that's going to form because of that. So now you've got your 2 points, you're just going to draw a straight line between the two, put arrows at the end, and of course label the x and y intercepts using Cartesian points. And there you have it.